Welcome. So the first trig ratio we're going to learn about is tangent. Right, so tangent is the ratio of the opposite leg divided by the adjacent leg. And you have this in your notes, and it's already written in the sides that you use for tangent. Right, so we take the tangent of an acute angle, meaning we pick an angle and we find the tangent ratio for that angle. Because the side that's opposite and the side that's adjacent is going to be different depending upon which angle we work with. So if we want to take the tangent of angle A, right? So this is our angle. This is our angle there. That, by the way, is just a variable that we use a lot for angles, and it's theta, the Greek letter theta, and it's just a variable. I can use an x, but theta gets used a lot for angles. All right, so if I'm looking at angle A there, opposite angle A is side A. The adjacent side, right, so this is opposite, the adjacent side makes up part of angle A, right, and is the other leg. That's not the opposite. Now we don't use the hypotenuse for tangent. We just use opposite and adjacent. Right, so there's from angle A's point of view. Right, so the tangent for angle A is side A over side B. And we would have values in there if we were solving. If you're interested in acute angle B, then, so here we are at angle B. Opposite angle B is side B. And now the side that makes up part of angle B, now angle A is the adjacent. So notice that adjacent and opposite depend upon which angle you're working with. Squeeze that in there. Right, so if you're interested in acute angle B, then A is the adjacent leg and B is the opposite leg. And so tangent of angle B would be B over A. Okay? And so all we're doing, by the way, in this lesson is not learning how to solve a thing. It's just learning how to set up the trig ratios. Right, so when the trig ratio is written, you always start with an acute angle as a starting point. By the way, for our trig ratios, we will never, ever start with the right angle. Let's write that in. We never use the right angle. Right? Always one of the acute angles. Suppose we want to find the tangent ratio for angle U. So remember, tangent is opposite over adjacent. Right? So if I'm at angle U, the opposite side would be side U, right over here. The adjacent side makes up part of angle A. And so right here is the adjacent. So the leg opposite to angle U is leg U. The leg adjacent to angle U is leg V. So the tangent of angle U is always going to be U over V. Side U over side V. Suppose we want to find the tangent ratio for angle V. Now we're using a different angle. So angle V's got a different point of view. Right? So now it's side V. That's the opposite side. And side U is the adjacent side because it makes up part of angle V. Right? So tangent ratio always uses opposite over adjacent. The leg opposite to angle V is leg V. The leg adjacent to angle V is leg U. So the tangent of angle V is going to be V over U. Because now V is opposite and U is the adjacent when you're looking from angle V's point of view. All right, so we've had letters. Let's put some numbers in there. All right, so we want to find the tangent ratio for angle R and for angle S. And tangent is always opposite over adjacent. All right, so by the way, make sure you're following along in your notes. A lot of these are in your notes. I think this one is in your notes. All right, and so you follow along. I won't always write down, hey, this one's in your notes, this one's in your notes. You just follow along and make sure everything in your notes gets filled in. All right, so here we have angle R, and I put the theta symbol because that's the angle we're interested in. All right, so the tangent ratio for angle R is going to be the side here that's 3. Actually, it's going to be side R, but the measurement is 3, right? So I'll just put a little, this is side R. But we have a number in there now. So this one is the opposite side. Right? And the adjacent side makes up part of angle R. So 2 here is the adjacent leg. Right? So the tangent for angle R is going to be the opposite side, which is 3, over the adjacent side, which is 2. And that is our tangent ratio. By the way, we always reduce to lowest terms, and we always keep it as a fraction in lowest terms. So this is in lowest terms because 3 and 2 don't have anything in common. All right, so now let's find the tangent ratio for angle S. All right, so now angle S has a different point of view. All right, so here's where angle S is. Let's get rid of all this because this isn't right anymore for angle S. I'm going to rewrite opposite. All right, so now it's this side that's opposite, right? Because this one now is across. Actually, I'll write in green. This one is across the triangle. So 2 is the opposite side, and now 3 is the adjacent side because this side makes up part of angle S. So the tangent ratio for angle S is going to be 2 over 3. And then we're done with this one. Another one done. Right, so I think finding these tangent ratios aren't too difficult. You just have to be able to identify who's opposite and who's adjacent. All right, so this is in your notes. This one I did put in your. I did put a little note to you that it's in your notes, but there are other ones. I think that last one was in your notes as well. You want to identify the correct tangent ratio for angle S. All right, so let's take a look here. All right, so in your notes, I want you to write that tangent theta here is opposite over adjacent, right? And theta is just a variable. We're using tangent S, and I left the words up here, all right, but you would have to decide which is the opposite and which is the adjacent. So the opposite side is always on the opposite side of the triangle from our whatever the acute angle we're interested in. So S here is the opposite side. The adjacent side is the leg that makes up part of the angle, right? So T here would be the adjacent side. And so our tangent ratio for angle S is going to be S over T, and that would be the correct answer. So in your notes, I was trying to be a little S and a little T there. All right, in your notes, you can write the tangent ratio for angle S. You can label the triangle, and you can circle the right answer. All right, so the opposite side is side S, and the adjacent side is side T. All right. I think I have one more problem here, right? And we're going to find the tangent ratios for 4 different angles, the 4 acute angles, because we never find any trig ratios for the right angle. Right? And we always reduce, and we always rationalize our denominators. So I believe this one's in your notes. So also make sure you reduce trig ratios and rationalize denominators. All right, so tangent for angle B. All right, so here's angle B. All right, so opposite angle B is the side labeled 10 because it's opposite on the opposite side of the triangle. The adjacent side makes up part of angle B. So it's the leg that makes up part of B, so that would be 6. So the tangent ratio for angle B is going to be 10 over 6. But that's not in reduced form because both of these are divisible by 2. So I could reduce that to 5/3. If angle C is the angle we're interested in, oops, these are connected. Now we're going to have a different opposite and a different adjacent. Oops, there goes part of C. All right, so now opposite the triangle is side, or opposite the triangle from angle C is side 6. All right, so side 6 is now, oops, I'll get rid of that line there. Side 6 is now the opposite, right, because it's on the opposite side of the triangle. And side 10 here makes up part of angle C, so it's the adjacent leg. There we go. So the tangent ratio for angle C is going to be 6 over 10. And both of those are divisible by 2. Right? So 6 divided by 2 is 3, and 10 divided by 2 is 5. Now let's look over at angle E and angle F. All right, so here's angle E. We're interested in angle E here. So we want the tangent for angle E. All right, so the opposite side is across the triangle, and the adjacent side is the leg that makes up part of angle E. Right? So the tangent ratio for angle E is going to be the opposite side, which is 2 square roots of 6, over the adjacent side, which is 1. Now we don't really need to put the 1 in the denominator, so that could be reduced to just 2 square roots of 6. Right? You don't have to have the 1 there. All right, and now let's look at the last one. So we have angle F. We want angle F's point of view. All right, so that's going to be our angle. And I'm going to get rid of all these things. Whoops, yep, figures. The word adjacent in the line got stuck again. All right, so the side opposite from angle F is going to be this side, this leg, right, which is labeled with a 1. This is now the opposite. Let's move opposite over. And now the adjacent leg is the leg that makes up part of angle F. That's located right here. All right, so the tangent ratio for angle F is going to be 1 over 2 square roots of 6. But that's not rationalized because there's a radical in the denominator. All right? So when we say rationalized denominators, we mean no radicals in the denominator. We don't care about the numerator, just the denominator. So if I multiply the numerator and the denominator by the square root of 6, I'm going to make what's in the denominator a perfect square, and then I won't have to worry about there being a radical. So 1 times the square root of 6 is the square root of 6. And then we have a 2. Square root of 6 times the square root of 6 is the square root of 36. Well, and we know that's just 6. All right, so here we're going to have the square root of 6. And I'm just going to put a little arrow here. This is just 6. And 2 times 6 is 12. All right, so that's going to be equal to, I'll write it nicer. So 2, oops, I put it in the wrong spot. 2 square roots of 36. Square root of 36 is 6, so it's 2 times 6. Right? And 2 times 6 is 12. So there's our answer in simplest, reduced, rationalized form, square root of 6 over 12. And I think that's the last one on this video, right? Because we're going to learn about a different trig ratio. All right, so bye for now. Thanks for watching.